Hello and welcome to the final exercise of this exercise series. So for this we're going to solve exercise I. So in this case we're interested in finding the integral of the square root of x times sinus squared. The sinus squared of x to the power of 3 over 2 minus 1 times dx. So integrated to dx. Okay, so I'll let you think about it. You already know you have to solve it by substitution, but what part, if you take the derivative of, is going to find basically its brother or sister within this, well, this composite function? So maybe I can rewrite it a little bit and it will become a little bit clearer. Sinus squared x to the power of 3 over 2 minus 1 derived to integrated to dx. Well, basically, if we were to substitute this, some interesting things are going to happen. You say, well, u is equal to x to the power of 3 over 2 minus 1. Okay, if we derive this now, what do we end up with? Well, we find that du derived to dx is equal to 3 over 2 times x to the power of, well, dropping the exponents, minus 1, 1 over 2. Oh, great, this seems to be matching, and that minus 1 just becomes 0. Or in other words, dx is equal to du over 3 over 2 x 1 over 2. Well, let's move that 2 immediately up, so we get here 2 times du. Okay, once we have all of this, well, we can fill that in and see what we end up with. So we get here the integral. Didn't substitute x1 to the power of 1 over 2, so we let that be. Here we get sinus squared, but now of u. And then dx becomes 2 times du over 3x to the power of 1 over 2. Okay, great. This indeed matches up because this and this neatly cancel each other out. There's some constant, so we can move it to the front. So actually what we're solving here is 2 over 3 times the integral of sinus squared of u du. Okay, if we want to do this, well, here you need to use a couple of tricks, because the sinus squared of u, well, it doesn't easily have an antiderivative. You can think about it, what you would need to do, but it would be quite cumbersome. But how can you make this a lot easier? Well, basically what's really messing us up is that exponential. And I'm showing this exercise with a very deliberate reason, is because, well, this is always going to be the strategy when you're dealing with these kind of exercises. So as soon as you have sinus squared of x, or in this case u, well, what do we know? We know that by using our trigonometric identities, we know that sinus squared of x is equal to 1 minus cosine 2x over 2. By using this and filling that into our integral, so 2 over 3, the integral, we get that this is 1 minus cosinus of 2u over 2. Okay, great. Well, this 2, let's already move that out. It's just a division by a constant, so we get here 2 over 6. So we get here 1 over 3. And now we have the integral of 1 minus cosine of 2u. Okay, let's split that up. So we get the integral of 1 du minus the integral of cosine 2u du. Okay, this one shouldn't really pose a problem anymore. We know that it's 1 over 3 times u. And this one, well, thinking about antiderivatives and that kind of stuff, well, what do we know? Well, we know that the cosine, well, if we go the opposite way, so if we were to derive sinus, we would then end up with cosinus. So we want to go the opposite way now, right? So what do we end up? Well, that this integral is the sinus ends us up with the sinus of 2u, because, well, if we derive that, we end up with cosinus 2u. But careful, if we apply the chain rule to this, we would still, well, 2 times 2, and that of course isn't written here, so we still have to divide 2 away, right? Comes from here. So imagine, if you really don't see what I'm talking about, just take this function and derive it once, and you should end up with this thing over here. And if that's not the case, it means that you missed something. Okay, so that would be the solution of that. And then of course plus c. Here I see that I've been careless because that 1 over 3 should still be over here, and basically we should open the brackets like that. So in other words, what we have 1 over, well, u over 3, we can say, u over 3 minus sinus 2u over 6 plus c. Substituting back what we originally had with, remembering what we substituted, so we get x to the power of 3 over 2 minus 1 over 3 minus the sinus of 2 times u, so x to the power of 3 over 2 minus 1, and all of that divided by 6 plus some constant. Let me rewrite it a little bit, plus some constant. So here we did a substitution, and this is the only one here in this series where you have to do also a trigonometric substitution. But this kind of tells us, well, what do you do if you have to solve this integral, cosine squared of u? Because that doesn't nearly, well, let's not say u, let's say x dx, because that doesn't neatly have a form where it reduces the exponent. Well, you need to do one more additional step. What can you do? You can say, well, first things first, we can rewrite it as 1 minus the sinus squared of x dx. And once you have done that, well, you see that now you're dealing exactly with the situation we had before, where you can do this substitution. Anyways, this is all about integrals, what you need to know for this week. I strongly encourage that you make all the exercises, because we're going to only build upon this and really try to make clear like how these basic things work, just as we did with derivatives. Really try to make the basics as strong as you can, and then the harder techniques will also come easier. Okay, that's it for this week. See you. Bye-bye.